Hello students and everyone, this is Gaurav Mishra and I welcome you all to GM Physics. I hope you all are fine and doing good. Alright, so let me introduce you with today's topic. What exactly we are going to study. So this is what we are going to study today. The topic is resolution of a vector in 3 dimension. Till now we had studied how to resolve a vector or how to take the components of a vector in a plane, that is along x-axis and y-axis. We used to take x-axis and y-axis. We used to resolve a vector into its components along x and along y. So today we'll be studying the resolution of a vector in 3 dimension. Why do we do that? All these things we'll see. So under resolution of a vector in 3 dimension, we have the following subtopics. What is that? First one is, we'll resolve a vector into its 3 components, namely x-axis, y-axis and z-axis. Along x-axis, y-axis and z-axis, we will take the component of a vector. So just now I told, why do we take the components of a vector in 3 dimension? If we could do it in a plane, then why do we need this? So this thing we'll study under this subtopic. Then, if a vector is given in its components, in its 3 components, x-axis, y-axis and z-axis, then how to find its magnitude and direction, that we will do. Means first of all, we'll resolve the vector into its components. We'll learn how to find the components of a vector in 3 dimension. Then we'll learn if a vector is given in its components, means if its 3 components are given, then how we will find its magnitude and direction, that we'll do here. And finally, we'll define terms called direction cosines for a vector. And we have already studied about unit vector in previous lectures. So here we'll do 2 things. First of all, we'll define direction cosines for a vector. Then we will find the unit vector of this given vector, and then we will relate the components of the unit vector with its direction cosines. Got it? Alright, so without wasting any time, let's begin. Alright, so resolution of a vector in 3 dimension. So the first topic will be resolving the vector into its components along 3 lines, along 3 axes, x-axis, y-axis and the new axis, that is z-axis. But the question is, why do we need to resolve the vector along 3 axes? If we were able to resolve the vector in 2 dimension, what was the need of resolution of a vector in 3D? Because till now we were doing like this. For example, a vector is in the plane of the board, anywhere like this or like this or like this, anywhere, doesn't matter. As long as it lies in this plane, we can resolve any of these vectors simply by drawing 2 perpendicular lines. We can draw one line like this, let's call it x-axis, and one line perpendicular to this, let's call it y-axis. Now any of these vectors can be resolved. This can be shifted parallelly and placed on the origin like this. Let's call this as A vector, this is B vector, this is C vector. You can also bring it at the origin. It's not necessary, but for simplicity, for convenience, you can bring it at the origin. Now you can resolve all these 3 vectors or any number of vectors. You can find its component along x-axis and y-axis respectively, right? So if we were able to find the components of the vector in 2 dimension, what is the need of this resolution in 3 dimension? Alright, so here the situation is like all these vector quantities are present in the same plane. Whatever be their orientation, whatever be their magnitude, as long as they lie in the same plane, it's very convenient and easy for us to take their components just by drawing 2 lines perpendicular to each other, and all the vectors that may be present in this plane can be easily resolved. Now look at a situation which is slightly different from the given situation and try to relate it. Just see here. Suppose this is a block, right? and this block is pushed by you with some force, let's say F1. Okay, your brother pushes it with a force, let's say F2, and your sister trying to push it along this line, right? So if we want to analyze or study the motion of this block under these three forces, one by you, one by your brother, and another one by your sister, so you'll have to look at the contribution of all these three forces together, right? But the situation is different from there. This F1 and F2 vectors, they lie in the same plane, that is in the plane of the board. But what about this vector, about this force? It is not in the plane of the board. It is inclined at some angle with respect to the plane of the board. Now when you go to analyze the motion of this body, so you can resolve the component of these two vectors simply by drawing two lines perpendicular to each other but in the plane of the board, x-axis and y-axis. What about this one? You won't be able to take its component along x and y alone because it doesn't lie in the plane of the board, right? So for complete resolution of the vector, we need to devise a method where all the forces, irrespective of their orientation, whether they are lying in the same plane or in a different plane, we need to devise such a setup so that all the vector quantities can be resolved and can be analyzed, right? So what we do, we simply do one thing. We take a line perpendicular to the plane of the board, right? And we give it a name z-axis. So now we have x-axis, y-axis and z-axis. Now we can resolve any vectors irrespective of their orientation and magnitude. I'll just show how, but this will make it possible. That's why we need resolution of a vector in 3 dimensions. So now we have one as x-axis, another as y-axis, and perpendicular to the plane of the board, this is called z-axis. This is called z-axis. Let me draw it perpendicular to the board. Assume this is perpendicular to the board. This is called z-axis. Now we can resolve any vectors. I'll show you how, but you have to know for right now that now you can resolve any vectors simply by taking one line perpendicular to the plane of the board, right? So this is what we are going to do, resolution of a vector in 3 dimensions. Now we will see how to resolve a vector in 3 dimensions. All right, so now we are going to resolve the vector in 3 dimensions. We have understood why do we need to resolve the vector in 3 dimensions. Now we are going to do it. So we have this new setup for resolving the vector in 3 dimensions. We are already familiar with this xy Cartesian plane, and this is sufficient to resolve any vector that is present in this plane. But in this new setup, whether a vector is present in this plane or is aligned at any angle with respect to this plane, whatever be its orientation, whatever be its magnitude, all vectors in this universe can be resolved in this new setup. So what is this new setup? The only difference is this used to be our Cartesian plane, xy plane. We have drawn a line perpendicular to this Cartesian plane. So these three together make a new setup called rectangular coordinate system. Now this will be used for resolving a vector in its 3 components, right? So now see, this you already know, along positive x-axis we denote it by I cap, a unit vector along x-axis. Along y-axis, positive y-axis, we denote by j cap, right? For our new line, that is what we call z-axis, this is represented by k cap. So like for negative x-axis minus I cap, for negative y-axis minus j cap. Similarly, for negative z-axis, it is called minus k cap. Positive z-axis, that is called k cap, and negative z-axis, that is called minus k cap. All right, so this much is clear. Now let's look at any vector in general. Suppose this is the vector, this is the vector, this is the vector. It is not in the plane of the board. You have to assume it like that. Let's call this vector as A vector, right? Magnitude of the A vector can be denoted as mod of A vector, right? So this is the vector with magnitude mod of A cap, or you can simply write A, right? And since it is a vector, so it has some direction. So how do we denote direction in this 3 dimension? Like in XY plane, it was very easy. This used to be the reference line. You could have shown any angle like 30 degree, or this is 110 degree, something like that. Vector anywhere, the direction can be easily specified just by choosing the reference line, that positive x-axis, and writing the angle, right? Here you will have to write 3 angles to give a unique direction. Since it is a vector, so it will have a unique direction, right? So suppose this A vector is aligned at an angle of alpha with respect to positive x-axis, at an angle of beta with respect to positive y-axis. We write all these angles with respect to positive x-axis, positive y-axis, and positive z-axis. So this alpha is with respect to x-axis of this arrow, of this vector. This vector makes an angle beta with respect to positive y-axis, and this vector makes an angle of gamma with respect to z-axis. This is not 180 degree. This is some angle with respect to z-axis, like this is the z-axis, right? So we have drawn in the plane of the board, so it is slightly confusing to understand. Look at this vector. Suppose this is the vector, okay? This is the vector, this is the z-axis. For right now I am removing this z-axis. Let have this vector. So it is making some angle alpha with respect to x-axis, some angle beta with respect to y-axis, and now z-axis for some angle gamma with respect to z-axis. That is what I have represented. Now I hope you understand angle alpha, angle beta, and angle gamma, right? Now we want to find the component of this vector along x-axis, along y-axis, and along z-axis. So how to find it? Same like this. If you want to find the component of this vector along x-axis, you simply have to drop a perpendicular from the head of the arrow on x-axis. The point of intersection of the perpendicular from the head of the vector and x-axis. So from the origin till the point of intersection, this is called x component. Similarly, you drop a perpendicular from the head of the vector on y-axis. The point of intersection of the perpendicular from the head of the vector and y-axis. The distance of this point of intersection from the origin gives you y coordinate. The same process you have to do here. So drop a perpendicular from the head of the arrow on x-axis, the point of intersection, measure the distance from the origin till the point of intersection. This will be called x component. Similarly, drop the perpendicular from the head of the vector on y-axis. This will be called y component. Similarly, drop the perpendicular from the head of the vector on z-axis. Drop the perpendicular. That is what we call this length from the origin till the point where it intersects. That is called its z component. So here it will be confusing, but you have to assume that I am dropping the perpendicular from the head of the vector on z-axis, this one. So this is what we call its z component, right? Let me draw it here once again. This is the vector, right? So I have dropped a perpendicular on x, dropped a perpendicular on y, and dropped a perpendicular on z. So this is my x component, this is my y component, and this is my z component. Are you getting it? This is my x component, this is my y component, and this is my z component. Now, how will we find this x, y, and z? This is what we are going to do. See here. Let me call the origin as O, this point as A, this point as B, this point as C, and this point as D. Are you getting? B is the point of intersection from the with the perpendicular from the head of the vector with x-axis. C is the point of intersection of the perpendicular from the head of the vector with y-axis. D is the point of intersection of perpendicular from the head of the vector with z-axis, right? So OB will be x component, OC will be y component, and OD will be its z component. So first of all, I am going to find x component, that is OB. So look in this right angle triangle OAB. In the right angle triangle OAB, angle is alpha and OB is the base of the triangle OAB. So can you write cos of alpha is equal to base upon hypotenuse, and this hypotenuse is nothing but the length of the arrow, that is the magnitude of the vector, that is equal to A, right? So cos alpha is base upon hypotenuse. So for x component, let's write here x component. For x component, we can write cos of alpha is equal to base upon hypotenuse. So base is x, which we want to find, and hypotenuse is a vector mod of a vector, that is a itself. Let's write mod of a vector. So what is the value of x? That is mod of a vector, that is magnitude of the vector into cos of alpha, right? Similarly, if we want to find its y component, look in this triangle OAC. The angle is beta. So cos of beta will be base, that is the y component, upon hypotenuse, again the length of the arrow, that is magnitude of the vector. So let's write cos of beta for finding y component. So y component of the vector. So now we'll write cos of beta in the right angle triangle OAC. So write cos of beta is equal to base. What is the base? The y component which we want to find, y upon hypotenuse, that is the length of the arrow, magnitude of the vector, mod of a vector. So from here you get y is equal to mod of a into cos of beta. A cos alpha is x component, a cos beta is y component. Alpha is the angle the vector makes with the x-axis, beta is the angle the vector makes with y-axis. So for x, a cos alpha, for y, a cos beta. Now let's look for z component. Alright, so this diagram will be confusing, so I am making it here. See, this is x-axis, this is y-axis, and this is my z-axis, right? And this is the vector which is aligned at an angle of gamma with respect to z-axis. This is the vector. So the angle between these lines is gamma. If you drop a perpendicular from the black one on this blue one, so this will again form a right angle triangle with angle being gamma, right? And this will form the base of that right angle triangle. Are you getting it? Let me draw it like this. This is the perpendicular, this is the vector. If you drop the perpendicular here, this angle is gamma, and this one will be the base of the right angle triangle, and this one will be the hypotenuse, right? So cos gamma will be base, that is base upon hypotenuse. Same like x and y. So here I am writing Z component. Now, so how will we get that? Simply using that triangle. Here you see it is OAD, right? So cos of gamma is equal to base. Base was the Z component, hypotenuse is the length of the arrow, right? So Z component will be mod of A into cos of gamma. So we have resolved the vector into its three components, the x component, y component and z component. So if a vector is given such that it is aligned at an angle of alpha with respect to x-axis, beta with respect to y-axis and gamma with respect to z-axis, then x component, y component and z component can be written like this. X is equal to mod of A into cos of alpha. Y will be written as mod of A into cos of beta, and Z will be written as mod of A into cos of gamma. These are the components of a vector in 3 dimension whose magnitude is given and the angle with respect to positive x-axis, positive y-axis and positive z-axis is given. One point I want to make it clear to you. You always have to measure the angle with respect to positive x-axis, positive y-axis and positive z-axis only. These angles alpha, beta and gamma can have any values and they will take care of the sign of the components. Whether the component is along positive x-axis, along positive y-axis, along positive z-axis, negative x-axis, negative y-axis, negative z-axis, it will be taken care by the angle itself if you measure with respect to positive x, positive y and positive z. So you always have to write x component as mod of A cos alpha, y component as mod of A cos beta and z as mod of A cos gamma. And you have to take care that these angles are with respect to positive x, positive y and positive z axis. So here I am writing alpha, beta and gamma are the angles the vector makes so here this point is important to note that alpha is the angle the vector makes with respect to positive x-axis. Positive axis. You have to measure with respect to positive x-axis. Similarly, beta is the angle the vector makes with respect to positive y-axis. Positive. All the angles are with respect to positive axis. Similarly, gamma is the angle the vector makes with respect to positive z-axis. Are you getting it? So all these angles have been expressed with respect to positive x, positive y and positive z-axis. So this is how we find the components of the vector in 3 dimensions. Alright, so let's take an example. A force vector of magnitude 100 Newton acts on a body along a line which is aligned at an angle of 60 degree with respect to x-axis, 60 degree with respect to y-axis and 45 degree with respect to z-axis. So the force vector acts along this line which is aligned at an angle of 60 degree with respect to x-axis, 60 degree with respect to y-axis and 45 degree with respect to z-axis. So what we have to do? We have to express the force vector in its components. Means you have to write these force vectors in its components like xi plus yj plus zk. Means first of all you will have to find the components of the vector. Means you will have to resolve the vector, right? So look here, we are going to resolve this vector. So for resolving the vector, we need to know the magnitude or the length of the arrow and its orientation with respect to different axes. So all this information is available in this question. The magnitude is 100 newtons and the angles with respect to x-axis, that is alpha is 60 degree, with respect to y-axis, that is beta is 60 degree, and with respect to z-axis, that is gamma, is 45 degree. So let's find it. Let me call this vector as f vector. F vector, magnitude of this vector is given as 100 newtons, right? Newton is the unit of force. So f vector is 100 newtons, mod of this magnitude. Angle with respect to x-axis, so we'll assume alpha, beta and gamma as with respect to x-axis, with respect to y-axis and with respect to z-axis. So alpha is 60 degree, beta is 60 degree and gamma is 45 degree. So now we can calculate the components. The x component will be nothing but magnitude of the vector into cos of alpha, right? So magnitude of the vector is 100 units and cos of alpha means cos of 60 degree. So cos 60 is 1 by 2. So 1 by 2 into 100, that is 50 newtons. Getting it? 50 units. Similarly, y component can be calculated as magnitude of the vector into cos of angle it makes with y-axis, that is beta. Beta is 60 degree and mod of f vector is 100. So magnitude of the vector is 100 and cos of beta means cos of 60. Cos 60 is 1 by 2. So 1 by 2 into 100, again 50. Similarly, z component. So z component can be written as magnitude of the vector into cos of angle the vector makes with z-axis. So that is gamma. Gamma is 45 degree. So we can write magnitude of the vector into cos of gamma is 45 degree. Cos 45 is 1 by root 2. So 1 by root 2 into 100, how much you get? 50 into root 2. So these are the components of the vector along x-axis, along y-axis and along z-axis. All these values are positive. It means this is along positive x-axis, this is along positive y-axis and this is along positive z-axis. Getting it? So now we can express the vector. What can we write? F vector as x component I cap plus y component j cap and z component k cap. The values of these components will itself tell whether it is along plus I or minus I, plus j or minus j, plus k or minus k, right? So x component is 50, x component is 50, so this is 50i, plus y component is 50, so 50j, plus z component is 50 root 2, so 50 root 2 k cap, right? So we can write the vector as f vector as 50 as common, so 50 I cap plus j cap plus root 2 k cap. This is the vector. Getting it? So this is how we resolve the vector. Alright, so now finding the magnitude and direction of a vector from its components. Till now what we did was a vector is given, means a vector's magnitude is given and its direction with respect to x-axis, y-axis and z-axis is given. Means the angle at which it is aligned with respect to x, y and z axis. So the length of the root, that is magnitude of the vector, and its angle with respect to x, y and z axis. This information is given. Then we could resolve that vector, means we could find its component along different axes and we could express the vector in its components form. That is what we have done till now. But now we are doing just opposite of that, a reverse process. What is that? Now we have been given a vector in its components form, means the components of the vector is given, the components along x, y and z are given and we are required to find the magnitude and direction of the vector. Means more clearly you can see it like this. Let's take some vector and name it as a vector. Let's say a vector, okay? And it is given in its components form, means its components along x, y and z axis are given something like this: L I cap plus M J cap plus N K cap. What it means? The x component of the vector is L, the y component of the vector is M, and the z component of the vector is N. This L, M, N can be negative or positive, integer, fraction, anything, right? So this is given. A vector is given in its components form, and what we have to do? We have to find the magnitude of this vector. We have to find the magnitude of this vector. We have to find the direction of this vector. Finding the direction means you have to find the alignment or the angle with respect to x-axis, y-axis and z-axis. Means you have to calculate alpha, beta and gamma, right? If alpha, beta and gamma are known, then you can find a unique line, means a unique direction which corresponds to this vector. So if you can find alpha, beta and gamma, it means you have found its direction, right? So we have to calculate the magnitude and we have to calculate the direction. Let me write it here. This corresponds to direction and this is the magnitude of the vector, which you already know, magnitude of the vector, right? So these things we have to calculate. So we'll do it one by one. First of all, I'm going to calculate the magnitude of the vector, and for that I'll be required to draw the coordinate system so that I can show that vector. See here, this is my y-axis, this is my x-axis, and this is my z-axis, z, x and y, right? This z-axis is out of the plane of the board, perpendicular to the plane of the board, outwards, that is positive. This is my vector, let's say a vector, and a vector is Li plus Mj plus Nj. It means if you drop perpendicular from the heads of the row on x-axis, the point of intersection, distance from the origin will be L. Similarly, if you drop perpendicular from the head of the row on y-axis, the point of intersection, distance from the origin will be M, and similarly on z-axis it will be N. So this is origin, and since when we drop a perpendicular on x, y and z, it gives L, M, N. So the coordinates of the head of the arrow will be L, M and N, right? X coordinate is L, Y coordinate is M and Z coordinate is N, right? All right. Now we are going to calculate the length of this arrow, means the magnitude of the vector, magnitude. So first of all, we are going to calculate the magnitude of the vector whose components are given as L, M and N. So see here, this is the origin, right, of this rectangular coordinate system. This is the origin. Its coordinates are 0, 0, 0. Okay. Now whatever points you choose on this y-axis, anywhere you choose, here, 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 wherever you go, only the y coordinate will change. The x and z coordinate will not change because there is no movement along x and z. You are moving only along y-axis, right? And this is true for any line parallel to y-axis. For example, if I take a line parallel to y-axis, right? So whatever points you choose on this line, they are going to have same x and z coordinate, only y coordinate will change. For example, this point has coordinate, let's say x1, y1 and z1. So if you go above, anywhere or down, doesn't matter, here the coordinate will be x1, y2, z1. Only the y coordinate will change. The x coordinates and z coordinates will not change because you are moving only along y-axis. Are you getting it? It means all points on y-axis will have same x and z coordinate, only y coordinates will change. Similarly, all points on x-axis or parallel to x-axis will have same y and z coordinates, only x coordinate will change. Same is for z-axis or any lines parallel to z-axis. All the points on a line parallel to z-axis will have same x and z coordinate, only z, x and y coordinate, only z coordinate will change because you are moving parallel to z-axis. So only z coordinates will change. There is no movement along x and y. Are you getting it? So the same concept will be using for calculating the length of the arrow. Alright, so I am dropping a perpendicular on xz plane from the head of this arrow. I am dropping a perpendicular from the head of the arrow on xz plane, and the point where this perpendicular intersects the xz plane, I am joining that point with the origin, right? So since this line is perpendicular to the xz plane and this line is in the xz plane itself, because this point lies in the xz plane, and I have simply joined this point with a line from the origin, right? So this angle is 90 degree. Now let's name it. This is origin. Let's call this as A and this as B. So OAB is a right angle triangle, right? Now, since this line is perpendicular to the xz plane, perpendicular to the xz plane means it is parallel to y-axis. So all points on this line which is parallel to y-axis will have same x and z coordinate, only y coordinates will change, right? Because it is parallel to y-axis, so when you are moving on this line, only y coordinate will change, x and z coordinates will not change because there is no movement along x and z. Getting the point? So if I want to write the coordinate of the point of intersection of this perpendicular with the xz plane, it will have the same x and z coordinate as any point on this line, and this head of the arrow lies on this line itself, and its x and z coordinate are L and N, so its x and z coordinate will be L and N respectively, right? What about its y coordinate? So this point lies in xz plane, so y coordinate will be 0, so this will be L 0 N, right? What exactly we are doing? We are trying to find the length of this arrow, right? And OBA is a right angle triangle. So if we can find this value and this value, then using Pythagoras theorem we can calculate this value. This is the hypotenuse of the right angle triangle. Getting the point? Now see, this point has coordinate L0N. X coordinate is L, y coordinate is 0 and z coordinate is N. It means if I drop a perpendicular from this point on x-axis, are you getting it? This will be equal to x. X coordinate means L, right? Similarly, if I drop a perpendicular on z-axis, this will be equal to z coordinate which is N. Are you getting it? So if this is N, so this length is also N, right? Let me call this as C and this as D. So OD will be equal to BC. So BC will be equal to N, Z coordinate, right? Now, in order to calculate this OB, which is the base of this right angle triangle, OB, we can see there is one more right angle triangle, OBC. OBC. So N square plus L square, root of that will be equal to OB. Root of N square plus L square will give OB. Pythagoras theorem. So this is equal to root of L square plus N square. Getting it? I have simply calculated the length OB. and OB is the hypotenuse of the right angle triangle OBC. We know the length of BC, that is equal to N, and we know the length of OC, that is equal to L, the X coordinate and the Z coordinate. Getting it? So now we know this one. Now we have to know one more value, that is BA, this length. How much is this? So it is parallel to y-axis, and this is 0 of y and this is m of y. So what is this length? It is equal to m, right? This is equal to m, right? So now in the right angle triangle OBA, the base is root of L square plus N square and the height is equal to m. So if you want to calculate the length of this arrow, means OA, so OA will be equal to root of base square plus perpendicular square, right? So simply using Pythagoras theorem, we have root of L square plus N square, base square plus perpendicular square. Perpendicular is m, so this is m square. So how much you get? Root of, this will become L square plus N square and this is m square. So simply the length of the arrow or the magnitude of the vector is L square plus m square plus n square. So we can write here magnitude of the vector, a vector mod of this, magnitude of the vector will be simply square root of sum of a square of its components, right? So mod of a vector is x component square, y component square, z component square, sum of this, and then take square root. This will give the magnitude of the vector. Same like we did for two-dimensional vector. There it was two components, here we have three components. So we have to add the square of all the components and then take the square root, we'll get the magnitude of the vector. Alright, so if a vector is given in its components form, that is x component, y component and z component, then its magnitude can be calculated as root of L square plus m square plus n square, means root of x component square plus y component square plus z component square. This will give us the magnitude of the vector. Now we are going to find the direction of the vector, means we are going to find the angle which this vector makes with different axes, x-axis, y-axis and z-axis. So the magnitude is already calculated, and if we find the angle it makes with different axes, then we can specify a unique direction as well. So we can find the magnitude also and direction also from its components, the same way as we did for a vector in two dimension. Alright, so see here, first of all I am going to calculate angle alpha. Then I'll find angle beta, that is with respect to y-axis, and then we will find the angle with respect to z-axis, and that we denote by gamma. Alright, so let's find the direction of the vector, right? So first of all, let's find alpha. We know the head of the vector has coordinates L, M and N, right? And its magnitude is, we just now calculated, root of L square plus m square plus n square. What we have to calculate is the angle alpha. The angle alpha is with respect to x-axis for this line. So I am dropping a perpendicular from the head of the arrow on this x-axis, right? Now let's name this as O, this as A and this as B. So in this right angle triangle OAB, if we want to calculate alpha, we can simply write cos of alpha is base, that is OB, upon hypotenuse, that is OA. How much is this OB? So you have dropped a perpendicular, like, right, and its x coordinate is L. So this one will be equal to L, right? So OB is already known, and this hypotenuse, which is the arrow length, magnitude of the vector, is already known. So we can easily calculate alpha. So we can write cos of alpha is equal to base, that is L, upon hypotenuse, that is L square plus M square plus N square. So we can also write as alpha is cos inverse of L upon root of L square plus M square plus N square. Got it? So this is alpha. Similarly, we can find beta as well by dropping a perpendicular from the head of the row on y-axis, right? And let's name this one as C. Again, if you see in this right angle triangle OAC, here beta can be calculated by writing cos beta is equal to base upon hypotenuse. And this base length is nothing but M, because the y coordinate of the head of the arrow is M. So if you drop a perpendicular, the point of intersection will be at a distance of M from the origin, right? So can you write cos of beta is equal to base, that is M, upon hypotenuse, that is arrow length, which is root of L square plus M square plus. So beta is equal to cos inverse M divided by root of L square plus M square plus N square. So this is beta. So cos alpha is L upon magnitude of the vector, that is root of L square plus M square plus N square. Cos alpha is equal to x component upon magnitude of the vector. Cos beta is equal to M upon root of L square plus M square plus N square. M upon root of L square plus M square plus N square. M is what? M is its y component. What is this? The magnitude of the vector. So x component upon magnitude of the vector will give the angle with respect to x-axis. M upon the y component upon magnitude of the vector will give the angle with respect to y-axis. Similarly, for gamma we can write as cos of gamma, the angle with respect to z-axis, will be equal to its z component, that is n upon the magnitude of the vector, that is root of L square plus M square plus N square. So now we have the magnitude as well as the direction. So if a vector is given in its components form, we can calculate its magnitude as well as direction. How we'll find the magnitude? Simply by adding the squares of their components. A square of x component, a square of y component, a square of z component. Add them and then take the square root. So here x component, y component, z component are L, M, N. That's why root of L square plus M square plus N square. Got it? So this is the magnitude. What about direction? So direction we find simply by writing alpha, beta and gamma, the angles with respect to x-axis, y-axis and z-axis. So here cos alpha, alpha is the angle with respect to x-axis. So x component upon magnitude of the vector, x component here is L, magnitude of the vector is root of L square plus M square plus N square, right? Similarly, cos beta, beta is the angle with respect to y-axis. So y component upon magnitude of the vector, y component here is M, magnitude of the vector is root of L square plus M square plus N square. So this is cos beta. Similarly, cos gamma, gamma is the angle with respect to z-axis. So z component upon magnitude of the vector, z component here is n, so n upon magnitude of the vector is root of L square plus M square plus N square. So this is how you calculate cos alpha, cos beta and cos gamma. They talk about the direction of the vector, because if you can find alpha, beta and gamma, you can give a unique direction which corresponds to the vector, right? Alright, so let's take an example. A vector is given as, a vector is root 2i plus j plus k. Find, first question, the magnitude of the vector, and second one is the angle it makes with respect to x-axis, means alpha. The angle at which this vector is aligned with respect to x-axis, this is what we have to calculate. Alright, so let's begin. The first one is you have to calculate the magnitude of the vector. So first of all, let's write the vector. A vector is root 2I plus j. J means 1j. J simply means that the component of the vector along y-axis is 1 units. Similarly, k means 1k. The component of this vector, A vector, along z-axis is 1 units. The component of this vector along x-axis is root 2 units, and so on. Getting it? So x component is root 2, y component is 1, and z component is 1. So we can find the magnitude simply by adding the squares of the components and then taking their square root. So we have mod of A vector, that is magnitude of the vector, as root of sum of a square of its components, x square plus y square plus z square, right? Z component square, which is 1. So how much? This is 2 plus 1 plus 1. 2 plus 1 plus 1. How much? 4. So that is 2 units. So this is the magnitude of the vector. So this is the answer for question number 1. Now let's look at question number 2, that is B. The angle it makes with respect to x-axis, means you have to calculate alpha, and we know cos of angle with respect to x-axis, that is cos alpha, will be x component upon magnitude of the vector, which is A vector here, magnitude of the vector, right? So what is the x component? Root 2. What is the magnitude of the vector? That is 2 units. So simply substitute the value here. X component is root 2 and magnitude of the vector is 2. So how much you get? 1 upon root 2. So cos of alpha is 1 upon root 2. So alpha is cos inverse 1 upon root 2, means 45 degree, right? So the vector is aligned at an angle of 45 degree with respect to x-axis. You can also find the angles with respect to y-axis and z-axis. Got it? Right. So final topic of this video lecture, direction cosines and components of the unit vector are same thing. This is what we are going to learn. Direction cosines. What are direction cosines? Cos of direction are called direction cosines. And direction is represented by, direction of a vector is represented by the angles it makes with respect to x-axis, y-axis and z-axis, right? So cos of angle with respect to x-axis, cos of alpha. Cos of angle with respect to y-axis, beta, cos beta. Cos of angle with respect to z-axis, that is gamma, cos of gamma. So cos of alpha, cos of beta, cos of gamma. This is what we call direction cosines. So suppose there is a vector, the one which we had taken before. I am writing the same vector for convenience so that you can write and recall those values, cos alpha, cos beta, cos gamma easily. A vector is Li plus Mj plus Nk. Now I don't need to tell all these things, you already know. L, M, N are the x component, y component and z component respectively for this vector, right? So Li plus Mj plus Nk. So if you want to find cos of alpha, so cos of alpha will be, alpha is with respect to x-axis, so x component upon its magnitude, that is L square plus M square plus N square, right? This is cos alpha. Cos of beta, angle with respect to y-axis, so y component, m upon root of L square plus M square plus N square. This you already know now. Cos of gamma with respect to z-axis angle, so z component, that is m here, upon its magnitude, root of L square plus M square plus N square, right? So this set is called direction cosines, cos alpha, cos beta, cos gamma. Now let's find the unit vector for the given vector. How to find the unit vector? We already know. Take the vector and divide by its magnitude. That is what we call unit vector. What does that represent? It represents a vector of magnitude equal to unity, and it is directed along the same original vector, right? Means if I divide this vector by its magnitude, I'll get a new vector whose magnitude will be unity, but will be directed along this line itself. Means if a vector is like this, then by dividing with its magnitude, you will get a vector like this. Magnitude is unity directed along the same line. So that is what I am going to find, unit vector for this a vector. So let's find the unit vector of a vector. So let's represent it by a cap, right? Unit vector. So the unit vector will be, unit vector a cap will be the vector divided by its magnitude. What is the vector? Li plus mj plus nk. What is its magnitude? We already know. Sum of a square of its components, root of that. So L square plus m square plus n square. Now let's write the components of this unit vector along x-axis, y-axis and z-axis separately. So for x component, I'll get L upon root of L square plus m square plus n square. This is x component, so I cap. I'll write I cap. Similarly, m upon the magnitude j cap. This will give its y component. So write m upon root of L square plus m square plus n square j cap along y-axis, y component. Similarly, n upon magnitude k cap, its z component. So we can write n upon root of L square plus m square plus n square. This will give its x component, right? Now look carefully at the components of this unit vector. This is L upon root under L square plus m square plus n square. Look here also, L upon root under L square plus m square plus n square, that is cos alpha. So cos alpha and the x component of the unit vector are same, right? Now look here, the y component of the unit vector a cap, m upon root under L square plus m square plus n square. And look for cos beta, m upon root under L square plus m square n square, m upon root under L square plus m square plus n square. So these two are same. The y component, the y component of the vector, unit vector, and cos beta, direction cosines. Similarly, look at the z component and look at cos gamma. Both are same. So the x component is cos alpha, the y component is cos beta, and the z component is cos gamma. So in fact, the unit vector can be written as cos alpha I plus cos beta j plus cos gamma k cap, right? So the direction cosines are nothing but the components of the unit vector for a given vector, right? So in that way, you can also write cos square alpha plus cos square beta plus cos square gamma will be equal to unity, because this is a unit vector, right? So its magnitude means square, that is cos square alpha plus square cos square beta plus square means cos square gamma, root of that will be equal to 1. You can check it, it will give unity itself. In the numerator, you will get L square plus m square plus n square. In the denominator, you will get L square plus m square plus n square. So that will give unity. So we can write an important result here. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. It will be used in problem solving as well. The sum of squares of direction cosine is equal to unity. First thing, and the components of the unit vector are same as the direction cosines for the given vector. Alright, so let's take an example and use the concepts that we have read so far. So a vector is given as f vector is I cap plus 2j cap plus 3k cap. I cap means 1 I cap, right? I cap or j cap or k cap, wherever you see, you have to understand it is 1 unit along x axis, 1 unit along y axis, 1 unit along z axis, right? So what we have to find, first one is the value of cos alpha, cos beta and cos gamma. Means we have to find the direction cosines for this given vector. And the second one is the unit vector along f vector, right? So you understand the relationship between the components of the unit vector and the direction cosines. So if we have calculated direction cosines, we can find the unit vector directly, and if we have calculated the unit vector, we can find the direction cosines from its components directly. Okay, so let's proceed by finding the direction cosines, and then we can find the unit vector directly. Getting it? Alright, so let's look at question number 1, the value of direction cosines. So first of all, cos of alpha. Alpha means angle with respect to x-axis the vector makes. So cos alpha will be the x component of the vector upon its magnitude, right? And what is its magnitude? So the magnitude of the vector f vector can be calculated as root of sum of squares of its components. X component is square, so 1 is square. Y component is square, so 2 is square. And Z component is square, so 3 is square. So how much you get? You get 1 plus 4 plus 9. So that is root 14. So cos alpha will be 1 upon root 14. Got it? Similarly, cos beta, direction cosine. Cos beta, beta is the angle with respect to y-axis. So we take y component. So 2 upon magnitude of the vector, we have already calculated, that is root 14. So root 14, right? And cos gamma. Gamma is angle with respect to z-axis. So we'll take the z component. So z component divided by its magnitude, divided by the magnitude of the vector, that is root 14, so root 14. So cos alpha is 1 upon root 14, cos beta is 2 upon root 14, and cos gamma is 3 upon root 14. So these are the direction cosines. So we can directly calculate the unit vector along f vector. We know direction cosines are the components of the unit vector. So we can simply write f cap as cos alpha I, means 1 upon root 14 I cap, plus cos beta j, so that is 2 upon root 14, so 2 upon root 14 j cap, plus cos gamma k cap, so that is 3 upon root 14 k cap. Getting it? So we can take 1 upon root 14 common, so we can write I cap plus 2j cap plus 3k cap. So this is the unit vector along the given vector. Got it? Alright, so let's look at the next example. It is based on direction cosines, right? So look here, the question is, the direction cosine of a vector is given as cos alpha is equal to 2 by 5 and cos beta is equal to 1 upon root 5, where alpha and beta are the angles at which the vector is aligned with respect to x-axis and y-axis respectively. As usual, alpha is with respect to x-axis, beta is with respect to y-axis, and the values are given. Cos alpha is 2 by 5, cos beta is 1 upon root 5. The question is, find the angle at which the vector is aligned with respect to z-axis. So alpha can be calculated, beta can be calculated, but we are required to find the angle, that is gamma, the vector makes with respect to z, right? So we can find it Very simple. We know the sum of squares of direction cosines is unity, because direction cosines are nothing but the components of the unit vector. So you can write cos square alpha plus cos square beta plus cos square gamma is equal to unity, right? The sum of squares of direction cosines will be unity. We already have the values of cos alpha and cos beta, so we can find cos gamma, and from there we can find the value of gamma, that is the angle the vector is aligned with respect to z-axis. So put the values. Cos alpha, so 2 by 5 square plus cos beta, so 1 upon root 5 square plus cos square gamma is equal to 1, right? So how much you get? 4 upon 25 plus 1 upon 5 plus cos square gamma is equal to unity. How much you get from here? If we take 25 as LCM, so this will be 4 plus 5 plus cos square gamma is equal to unity. So what you get here is 9 upon 25 to that side, so it will be subtracted. So cos square gamma is 1 minus 9 upon 25. What is that? 25 minus 9, 16 upon 25, right? So cos gamma is equal to root of 16 upon 25, so that is 4 upon 5. So what will be the value of gamma? So we know tan 37 is equal to 3 by 4, right? So cos 37 will be 4 upon 5. Is that right? Base upon hypotenuse. So base is 4, perpendicular is 3. So sin 37 will be 3 by 5, cos 37 is 4 by 5. So here gamma is equal to 37 degree. Got it? So this is the angle at which the vector is aligned with respect to z-axis. Alright, so this is what we had to do in today's video lecture. We'll again meet in the next video lecture with fresh energy. Till then, keep practicing, keep learning. All the very best. Take care. Bye-bye.